5, Day 5, Domain and Range. To begin with, as always, we have some warm-up problems. So I would encourage you to pause the video, work the problem out, see, and then play the video again and see if you got them right. So I'm going to give you a second to pause that, and then I'll get working. All right, welcome back. So, given f of x equals 6 times 1 minus x, what's the value of f of negative 8? That means you're replacing x with negative 8. So if you plug that in, 6 times 1 minus negative 8, you should get a value of 54. And this would be an EOC question where you actually had to bubble it in. Number 2 is a linear equation with variables on both sides. And I'm going to trust that you know what to do there, and you get the value of m equals negative 3. Remember, distribute, combine like terms, move variables, add, subtract, multiply, divide. Don't call me a monster. Number 3, 4 times the difference of twice a number and 3 is 20. Solving that, you should get n equals 4. On to domain and range. Sometimes domain and range are continuous over a given interval. There are no breaks. Remember what that means. An AND-type compound inequality is used to show the domain and range. So the x's are between negative 5 and 1. Not including 1 because it is an open interval. Actually, no, it's solid there, isn't it? It's open over there. We assume that it's going to be solid right there. So it is solid from negative 5 to 1. It's open at negative 5, so we have no line there, but we do have 1 for 1. The range, so the domain is always going left to right. That is the big deal there. It is how far this graph stretches from left to right. Because left to right, that's the x's. That's our x-axis. Range is from bottom to top. I feel like I have to write this one out. Bottom to top. The lowest that it gets down here, way down here, this function, gets down to negative 5. And it's open. It's open, so it goes negative 5 with no line. And it goes all the way up to positive 5, and it includes that. It's a solid dot there. It is closed, so we have a less than or equal to. That is what a lot of this is going to be. When they are continuous, this is what they look like. Discrete, a little different, but continuous, and most things are continuous. All right, number 1, find the domain and range of each function. So I'm going to take a different color here. The domain is going to be where it lives going from left to right. So it looks like it starts at negative 5, and it goes all the way until we get to 5. Okay, so our domain is going to be from negative 5, less than or equal to, it's closed, x is less than or equal to 5, from left to right. And the range, the lowest it gets, is down here at negative 6, all the way up to positive 2. So negative 6 is less than or equal to y, it's less than or equal to positive 2. From bottom to top, negative 6 up to 2. Number 2, we go domain. We start at negative 4. It's open at negative 4. And it goes all the way until you get to being closed at positive 2. So we have negative 4 is less than, x is less than or equal to positive 2. And then range, bottom to top. So the lowest it gets is down here at negative 2, and it's open. Goes all the way until you get closed at positive 4. So we have negative 2 is less than y, is less than or equal to 4. Number 3, left to right, it goes from 0, it's closed at 0, all the way over to positive 4, and it's closed there. So from 0, less than or equal to x, less than or equal to 4. Now I have something nice and interesting here because the range goes from 0, it's closed there, continues until it's closed at positive 4. So we get 0 is less than or equal to y is less than or equal to 4. These do not say the same thing at all. The domain says it lives from 0 to 4, going left to right. The range goes from 0 to 4, going bottom to top. So it really means it lives in this little grid, 4x4 grid. They do not say the same thing. Okay, so the x in the middle or the y in the middle makes a big difference. Make sure you are careful about that. All right, number 4. We have some that are a little bit different. So we can't actually say, here, it's really common to try to say, oh, it goes from -2, it's closed, all the way up to +3, and it's closed. That is not true. It exists at -2, then it skips everything there, it goes to -1, then it skips there to 0, you see what I'm doing? Skips there to 1, skips there to 4. So the way we write this is actually going to be as a list, like we did linear regression. -2, comma, -1, comma, 0, comma, 1, comma, 3. Our range is going to be where it lives. I cannot believe that I just did that. I just showed you the range and said it was domain. I even have it written down correctly. Why did I do that? So the range is where it is on the y-axis. Okay, so this is actually the range. Let's correct that real quick. I'm happy to admit that I made a mistake. We have -2, -1, 0, 1, and 3. But going in the x direction, okay, looking where it lives going left to right, it starts at -2, or -3, then -2, then we have that point right there, so it's 0, point at 2, and a point at 4. So -3, comma, -2, comma, 0, comma, 2, comma, 4. All right, so on number 5, we should get for our domain -4, -3, nothing there, all the way to 0, to 2, to 3. So our domain is -4, -3, 0, 2, 3. And our range, going from bottom to top, the lowest it goes is at -4, then at -1, so -4, -1. Then we've got a point at 2, at 4, and at 5. Okay. Number 6, we actually have some context here because hours worked, so the amount charged depends on the number of hours worked. All right, so our domain is where it lives going in the x direction. Domain is x. So it lives from 0, and it actually continues. There are no breaks. Well, there are lots of breaks, but there's always a value there. So it actually is everything. It keeps going until right at 6, in which case it's open up here. Might not be able to see that, but it's open. So it goes from 0 to 6. X is, let me do that differently. From 0, less than or equal to x, is less than 6. Now the range, we're going in the y direction. So we have 10 is where first place it hits. Then it skips a bunch up to 20, skips to 30, skips to 40, skips to 50, and skips to 60. So our range is actually going to be a list. 10, 20, 30, 40, 50, and it gets to 60, right? 40, 50, 60. And we have a list there. Okay, next, describe the domain and range for each function shown and evaluate the function for the given domain and range values. All right, so first we can just find the domain and range. It goes from left to right, from -3, and it's closed, to 5, and it's closed. So it is negative 3 less than or equal to x less than or equal to 5. The range, it goes from 2, and it's closed, to 5, and it's closed. So 2 is less than or equal to y is less than or equal to 5. And f of 2 means where the x is 2. So if we go to where the x is 2 and trace up to our graph, that graph is up here at 4. So f of 2 equals 4. Number 8. The domain, it lives from negative 2 and it's open over to 1 and it's open. So negative 2 is less than x is less than 1. The range, the lowest it gets is negative 3 and it's open, all the way up to 3 and it's open. So negative 3 is less than y is less than positive 3. And next it says when y equals negative 1, what is x? So if we look on the y-axis where we have negative 1, and it looks like it actually is right here. The point there is 0, negative 1, so x is 0. And please ask me questions in class if you realize something is just tricky. Ask your teacher, and if I'm your teacher, ask me. Number 9. Domain, where we go from left to right. Well, the farthest to the left it gets is somewhere right around, it looks to be negative 2.5. It's closed, and it goes all the way to the right at positive 2.5. So negative 2.5 is less than or equal to x, it's less than or equal to 2.5. And range, the lowest it gets is negative 3, and it's closed. The highest it gets is actually up there at positive 3, and it's closed. So negative 3 is less than or equal to y is less than or equal to 3. And then it asks, when y equals negative 3, what is x? So let's look at y is negative 3. Okay, where does it hit our graph? Looks like we've got right here, which traces up there, and right here, which traces up to there. So the x values are negative 2.5 or 2.5. There are actually two places where y equals negative 3. Okay, number 10, domain. This function going left to right, it lives between negative 3, it's closed, and positive 5. So negative 3 is less than or equal to x is less than 5. It's not equal to because it's open. Now the range, the lowest it gets is negative 3, and it's closed over there, and the highest it gets is also negative 3. So our range actually is just in braces, it's a list, negative 3. That's the only place that it lives in the y direction. Now, f of 2, go to x where x is 2, and trace down to our graph, and it looks like we are right here back at negative 3. f of 2 equals negative 3. Number 11, what's the domain of this function? First off, we know domain is inputs, it's independent, and it's x. So that means we can eliminate f and g. Now in the x direction, I don't know what these numbers are right here, but these are all bigger than 0. So x is greater than or equal to 0. Number 12. These usually go really fast. The domain is the list of all the possible x's. So the x's here are 1, 3, 4, 6. Those are all our x's. Same thing with 13. We're going to have a list. We're going to have 12, 11, and 10. And since it's a list, we only have to write 11 once. Our range, however, is going to be the list of the y's. So our range is going to be 3, 1, 6, 4. On this next one, we have 0.6, negative 0.15, 0.15, and negative 0.8. There's our list. To tell if it's a function or not, we have to check, do the x's repeat? And for 12, that is absolutely, they do not repeat. So this one is a function. It is a function. f of 1 is the value at where x is 1, so that is 3. Now number 13, though, is it a function? Well, do the x's repeat? Well, we have 11 actually going to two different numbers, so that is not a function. Number 14, domain, our list of x's. So we have -3, -5, -7, -13. Our range is our list of y's. That is 7. We've got 7 twice. We have 4 twice. That's it. Do the x's repeat? X's do not repeat. Therefore, this one is a function. Next thing we're asked is when y equals 7, so when y equals 7, what is x? Well, it's -3, and it's also -13. So x equals -3 or -13. Number 15 and 16, we're going to do the same sort of process. We're going to list out our x's. In ordered pairs, the x's always come first. So our domain is 2, 3, 5, 6. The range is 7, 7, 7, 7. So that's the only thing on our list. The question is it a function? Do the x's repeat? 2, 3, 5, 6. The x's do not repeat, so it is a function. And then f of 3 means when x is 3, what is y? When x is 3, y is 7. 16, we have 6, -5. Don't need to write -6 again, or +6 again, and we have -8. The range is 4, 2, 7, 8. Is it a function? Do the x's repeat? The x's, 6, -5, 6. Yes, the x's repeat, so it is not a function, with different y values, actually. And when y is 8, x is -8. There's 16. 17, 18, same sort of thing, so we draw the mapping. So 1 maps up with 3, and our x's go over here, our y's over here. 1 matches with 3, 3 matches with 1, 4 matches with 6, and 6 matches with 4. So our domain is the list that's in our x oval there, 1, 3, 4, 6. And our range is 3, 1, 6, 4. It does not matter what order you write those in. And it is a function because the x's do not repeat. Or if you remember from before, none of our x's are shooting 2 arrows. That'd be illegal. All right, next we have 2 goes to 7. Then we have 3 goes to 7. I've already written it, so I'm not going to write it twice. 4 goes to 8. And 5 goes to -2. X's and y's. So our domain is 2, 3, 4, 5. Our range is 7, 8, -2. And it is a function because none of our x's repeat. None of our x's are going 2 different directions. Number 19. The relation between the number of hours a person brushes their teeth, T, and the cavities they have, C, is given by the function C equals 2T. In this relation, what would represent the domain of the function? Now we need to know some terminology here. Domain is also the inputs. It's the x's. It's the independent variable. So in this case, I think I would like to write something to the effect of cavities depend on time to brush. Cavities depend on time to brush. So the independent is the time to brush. So time to brush, the number of hours they spend brushing, T. It's worth noting, though, however, the hours they brush to doesn't make any sense. The cavities they have, that was something they discussed in the problem. The number of days they brush, they never discussed that either. So really it was down to these two. Okay? Number 20. The function f of x equals, we have a list of ordered pairs, can be represented in a variety of different ways. Which of the following is the most accurate representation of f of x? The first thing I want to look at is these two right here because that's the easiest way to look at it. Negative 3, 9. Well, is negative 3, 9? That would be a point right about here. That does not match up. That doesn't match it from the get-go. Negative 1, 3 doesn't match either, so C is just out. D, we have negative 3 matches up with 9. That checks out. Negative 1 matches up with negative 3. No, it should be positive 3. So D is out. Now the only question is, which one of these two it is? So these are domain, these are x values. So plug these in for x. So if you plug negative 3 in for in here, negative 3x, that would give you a positive 9. That checks out. Negative 1 times negative 3 is positive 3. Negative 1 should go to positive 3. Check. 1 should go to negative 3 if we multiply that, which checks out with our word pairs up here. And 3, that would be a negative 9, which does indeed check out. So since they all do work, I'm going to go ahead and select this. But the next thing you could do is plug these in. These are range. Plug these in for y. So plug that in right there. Negative 9 divided by 3 is negative 3. So that means negative 3, negative 9. That does not work. And A is indeed our answer. Number 21, an electrician charges $75 plus $50 for each hour of work. The function C of H equals 75 plus 50H, change that on your paper, it should be an H, describes the amount of money in dollars that the electrician charges for H hours. What is the domain? So the domain is pretty obviously the H. Okay, so the H is what we're treating as our X. So the question is, how many hours can you have? So integers means positives, negatives, whole numbers. All whole numbers. So can you have a negative 5 hours? Would they charge you for that? No, because there's no such thing as negative hours. All real numbers includes positives, negatives, decimals. So could you have negative 3.5 hours? No, can't have that. You also can't have just any old hour above 0 because they're going to charge you for whole hours. $50 for each hour. So you can have only 1, 2, 3, 4, 5. That's actually going to be D. The answer 21 is D. All right, now 22. What's the range of the following function? We ran into this earlier. We want range, we're looking at our y values. So anything with x in it, J and G, those are both out. Now our y values are negative 3. I don't know if you can read that, but negative 3. It skips to negative 2. It skips to negative 1. So since it is not continuous in that fashion, F is our answer. All right, that brings us to the end of our domain and range notes. For my random math fact of the day, it's a common joke among mathematicians that, you know, I was working on that, but all night I had a donut and a coffee cup, and I couldn't figure out which one I was supposed to dunk. Because there's in a thing called topology, the shape matters, not the size, just the shape. So in that sense, a coffee cup has one big hole in it, right? Has one big hole in it, and a donut has one big hole in it. So, according to most mathematicians, these two are basically the same thing. So, tune in next time for, well, actually the review is what's next, so your next unit. So I might hear you or see you that next unit. So, signing off.